Sir, I have one doubt.
1 minute. Yeah, hi guys, welcome back. In the last session, we completed our discussion related to API gateway. What is API gateway? How to create API gateway and how to configure filters and routing in the API gateway. And we are able to complete our microservices project setup. In this, we created service registry. We are using Eureka as a service registry that will register all the services available in the application. And we are using admin server that is used to monitor and manage our applications at one place with a beautiful user interface. Then after we created our backend APIs are our RESTful services, and we are able to establish communication from one API to another API by using PN client, that is inter-service communication. And we have seen how to distribute the load from one server to multiple servers by using multiple instances of our APIs. And we have created API gateway, which is acting as a front gate for all the APIs. Whenever request comes to the API gateway, that will execute a filter. Once the filter is executed, it will perform some checks to decide whether to process this request or not. Then routing will be available. Routing is used to decide which request should go to which server in the backend. This is what we have developed in the previous class. Okay, guys. Now, anybody having any questions on this? Now, you can ask me the questions. You can unmute your mic.
Hello, sir.
Yeah.
I have one doubt in service registry side, Eureka side. We use
Yes,
the rate of enable discovery client, correct?
yes.
I have seen at the rate of enable Eureka client also. So what is the difference both?
I already told the difference. Enable
Sorry. Yeah, actually I missed the class.
Enable discovery client annotation will automatically search for the Eureka server which is running, and it will register our application with the Eureka server.
Okay.
Enable Eureka client means manually we need to register our application with the Eureka server. Discovery client means it will identify the Eureka with the 8761 port number.
Yes,
automatically will happen.
Yes. Another thing, sir, we implemented interface for that fin client purpose.
Correct.
So we will use class also, or is
so PN client will be implemented with the interface only. For that interface, implementation will be provided in the runtime. So in the JPA we have seen, right? JPA repository.
Yes. Yeah.
There also we use the same concept, right? We will create a JPA repository. Implementation will be available in the runtime. Here also same concept.
Sure. Yeah. Thank you very much.
Yes, sir. Next question. Come on, guys. What is your next question?
Hi, sir. In a service registry, do we have only Eureka server or any real-time other server?
So Eureka server from the Spring Cloud, we are having Eureka, and as an alternate for the Eureka, AWS will provide its own service registry. PCF Cloud will provide its own service registry, and there is another service registry available which is called Console. Like that, there are several available. From the Spring Cloud, we have Eureka server as a service registry.
Okay. But if it is a non-cloud application, then Eureka is the production-based service registry.
Right. If your application is deploying into the AWS Cloud will provide its own service registry.
Okay. Thank you.
Yeah. Hello, sir. Good evening, sir.
Yeah. Hi, sir. Good evening.
Sir, I heard about today I searched a website, sir. There I found that SOA architecture. So
service-oriented architecture.
Yes, sir.
Yep.
Difference between microservice and SOA architecture, sir. That also service business, same. Exactly.
Yeah, I will explain that. I will cover that. Difference between SOA and microservices. Both are almost same. Minor differences are there. We'll discuss that in the coming classes.
Okay, sir.
All of you able to develop this project using microservices?
Yes, sir.
Anybody facing any issue? Anybody facing any issue in this project development? Good. So with this, we completed our discussion related to our project. And here we understood what is microservice, what is monolith architecture, and what is microservices architecture, and how to work with service registry, and how to work with admin server, how to work with API gateway, and how to work with the filters and routings in the API gateway, and how to work with the inter-service communication by using FIAN client. Next one, guys. So we need to discuss about Slate and Jipkin. The next one is we need to understand what is a Slate and what is a Jipkin. Now here in the microservices, several REST APIs will be available. As part of application execution, one REST API can communicate with another REST API. As we have seen that when we are sending a request for the welcome API using FIAN client, and welcome API communicating with the greet API. That is called inter-service communication. Microservice application means several REST APIs will be available. As part of application execution, one REST API can communicate with another REST API. So now when we send a request from the UI, it will process by multiple REST APIs with inter-service communication. End user will send a request. That request will go to API gateway. From the API gateway, it will go to service registry. From the service registry, it will go to welcome API. From the welcome API, it will go to greet API. And greet API will give the response to welcome API. Then welcome API will give the final response to the end user. So like that, multiple APIs will be involved in our request processing. Multiple APIs will be involved in our request processing. When multiple APIs are involved in the request processing, how we can understand which REST API is taking more time to process our request? Now, when I make a request, 3 REST APIs involved in the request processing. How can we understand how much time is taking by welcome API to process our request? How much time taking by greet API to process our request? Okay, so I need to understand request processing time, and I need to understand how many APIs involved in my request processing. That's where Slate and Jipkin comes into picture. By using this Slate and Jipkin, we can identify which request is processed by which APIs and how much time has taken by each API to process the request. So whenever we use Slate and Jipkin in our application, Slate will generate a trace ID and span ID for our request processing. If we add the Slate dependency in the REST API, then it will add span ID and trace ID for the log messages. So whenever we run our application, for example, let me run the service registry, run as Spring Boot application. When I'm running this Spring Boot application, here you can see several log messages will be printed on the console. When I'm running this application, several log messages will be printed on the console. When the log message is printing on the console, we need to add Slate dependency, right? Whenever we add the Slate dependency, that is going to generate a span ID and trace ID for the log messages. For every request one, trace ID will be generated by Slate. For every request one, trace ID will be generated by the Slate. So once the request processing is completed, then span ID will be available. By using trace ID and span ID, we can understand how many services involved in our request processing. This Slate and Jipkin are used for observability. Now see here, my logs are printing, but in the logs currently, the trace ID and span ID is not available. Now I want to add Slate dependency in my project. Go to Greet API, go to pom.xml, In this pom.xml, we configure currently Actuator, Web Starter, Admin Client, Spring Cloud Slate Jipkin, and Spring Cloud Netflix Eureka Client. So here, Slate Jipkin dependency available, we need to add only Slate dependency. So let me go for Slate dependency here. So earlier I was not able to get that when I'm creating the project. Let me try to get that. mbnrepository.com Slate. I need to get the Spring Cloud Starter Slate. Spring Cloud Slate Jipkin I have already added. Spring Cloud Starter with Brave. I need to take this dependency. So let me take this dependency here. Spring Cloud. This is a new version for the artifact. Spring Cloud starter slate. Let me add this before the Jipkin. I'm removing the release. Spring Cloud starter slate dependency I'm adding in my pom.xml. Okay. Same thing, let me add in my welcome API also. Same thing, let me add in my welcome API also. Now go to welcome API, go to pom.xml. Here also Spring Boot Cloud Starter Slate Jipkin available. And let me add Slate Starter. Let me add the starter slate dependency. Okay. I have added starter slate dependency. Let us see, is it going to register with the Jipkin server or not? Now my service registry is running, guys. So go here and access that service registry, which is localhost colon 8761. Localhost colon 8761. Currently in my service registry, no instances are available. Clear this? Now let me go and start my admin server. Admin server that is used to monitor our applications at one place. I'm running my admin server. Admin server will be running on the port number 1111. Let me try to access that. I'm able to access my Eureka server, which is running on the 8761. Currently, no instances are registered with Eureka. My admin server project is started. Let's go here. Localhost colon 1111. Now, admin server is also started. No applications are registered. Similarly, let me run my Jipkin server. So Jipkin server is available as a jar file. Let me take that CMD here and let me try to run my Jipkin server. So Java space -jar space Jipkin. Jipkin is available as a jar file. I'm going to run that by using jar. Jipkin server will run on the port number 9411. So this Jipkin server is available as a jar. I have downloaded that jar. I'm running that jar file by using Java command. Jipkin server will run on the port number 9411. Let me access Jipkin dashboard, localhost colon 9411. Localhost colon 9411. So when I execute this, my Jipkin server is ready, but currently in the Jipkin server, no service is registered. Currently in the Jipkin, no service is registered. Okay. Now let me execute my applications, backend APIs, Greet API, Welcome API. For the Greet API, earlier I have removed the port number, guys, to show you the load balancing. Now I will add the port number. So server.port number. Now I will run that in only one instance. We understood what is load balancing, how to do that. Now server.port is equal to 9091. I'm giving for the Greet API. Refresh this, do the Maven update. So in the last session, to show you the load balancing, I have removed the server port from that. So now I have added server port as 9091 for my Greet API. Okay. Now let me run my Greet API, run as boot application. Run as boot application. My Spring Boot application is getting started. Now, let us see here. Yeah, boot application is getting started now. Go to this and refresh Eureka server. So Greet API is available. So 9092 port number. I think it has taken from the arguments that we have given. It has taken from the arguments we have given. Now you see here, when I started my application, you can see in the logs, some IDs are generated. These are called trace IDs and span IDs. In the logs, trace IDs and span IDs are available. And similarly, let me start my Welcome API, refresh this, refresh Welcome API, update Maven project. Already in the configuration, run arguments, the port number is available. So it has taken that port number 9092. Greet API started with the port number 9092. It registered with the admin server as well. Now go to Jipkin. Currently nothing is available in the Jipkin. Now go to Welcome API, right click, run as boot application. I'm running my Welcome API as well. welcome API will be running on the port number 80 series. It has taken from the run arguments, which I have given in the last session. Now, my welcome API is getting started. Clear the console. Now, go to Eureka. Now you can see welcome API is running with the port number 8082. Greet API running with the port number 9092. That is fine. Now go to API gateway, run as boot application. So API gateway will be running on the port number 3333. API gateway is used to manage all the backend APIs. Any request which comes to the API gateway, filter will be executed, then routing will be executed. All right. Now, once this API gateway is started, go to Eureka dashboard. Now in this Eureka dashboard, we can see that welcome API 8082, greet API 9092, cloud API gateway 3333. So you can see in the admin dashboard, greet API, welcome API running. In the Zipkin currently, nothing is showing here. Nothing is showing in the Zipkin. Now go and make a hit for the API gateway. API gateway running on the port number 3333. So go here, localhost : 3333/greet. I'm making a request to the greet API. So one server is available that is giving the response for me. Let us make a request to welcome API, localhost : 3333, then go for welcome. When I send the request for the welcome, inter-service communication available. Good evening message is coming. Welcome to Ashok IT message is also coming. So with this, we are able to hit both welcome API and greet API. Now see, now in my Zipkin server 9411, my Zipkin server is running. So earlier when I click on the run query, I did not get any output. Earlier when I click on the run query, I did not get any output. Now when I click on the run query, I'm getting the output. Here it is called observability. Here the Zipkin server and Slate and Zipkin are used to monitor our API's performance. Slate and Zipkin are used to monitor our API performance. So here I have sent two requests for my API. First request I sent to the greet API. Second request I sent to the welcome API. So if you go to the Zipkin, it is showing two results. When I click on run query, two results are coming. Suppose if I send one more request for the welcome API, now go to Zipkin, run the query. You can see three requests are there. That means for my APIs, I have sent three requests. Which request I have sent to which API, how much time it has taken to process each request, and how many APIs involved in the request processing, all that information can be monitored by using Zipkin server. So you see here, my backend API is registered with the Eureka server. My backend API is registered with admin server. My backend API is registered with the Zipkin server. So yesterday, the previous sessions in the last week, when I send the request for my backend APIs in the Zipkin server, I was not able to get the result. But today, I'm getting the results in the Zipkin server. What is the change I made? I have added this Slate dependency. When I'm creating the boot application, I did not get the option to select the Slate dependency. So if you want to integrate your REST API with the Zipkin server, you need to add Slate starter in the pom.xml. So Slate Zipkin dependency is available along with this Spring Cloud Starter Slate dependency. This new dependency we have to add in our pom.xml. In the welcome API, I have added this dependency, and in the greet API also, I have added that dependency. In the welcome API, I have added the dependency. In the greet API also, I have added the dependency. Now, when I send the request for my backend APIs, I'm able to monitor their performance in the Zipkin dashboard. Zipkin is open source server. It is available as a jar file. I have downloaded that jar file and I have executed that jar file. Then Zipkin server started with the port number 9411. With port number 9411. So now see here, first time, whatever the request that I have sent and whatever the response I got, how much time it has taken to process that, I'm able to get that. Now see here, when I send the get request with the /welcome, now it is showing that trace ID generated, welcome API executed, and internally welcome API communicated with the greet API. When I send the request for the only get request with the greet, it is showing that one trace ID got generated only greet API involved in the request processing. When I send the request for the welcome API involved and greet API also involved in the request processing. And how much time they have taken. Here they have a show option. When I click on the show option, it is going to show you. So here you send the request for the welcome. Welcome internally communicated with the greeter. Greet API has taken 16 milliseconds to process. Total time taken by welcome API is 201 milliseconds. So at what time our server is started, how much time it has taken, what request we have sent, what is the path available, that path is binded to which controller class, which method is executed. Every information we are able to access by using this Zipkin and Slate. These are the span IDs. For welcome API, I send a request, one span ID created for the welcome API. Welcome API has taken, this is the time I have sent the request. This is the URL pattern. For the welcome API, I have sent a get request with /welcome at 7:57. It has taken total 201 milliseconds. But internally, there is a inter-service communication. When I make a request to the welcome API will internally communicate with the greet API. So for the greet API, this is span ID generated. Welcome API send a get request to the greet API, get/greet. This is the time. At 7:57:16 seconds, I send a request for the welcome. At 17 seconds, it sent the request to the greet API. Greet API processed that request within 16 milliseconds. Total time taken by welcome API 201. In that 16 seconds taken by greet API. So like this, we can monitor our API details by using this Slate and Zipkin. If I go for only greet API request, click on show. Here, I send a request for the greet API. When I send a request for the greet API, only greet API involved in the request processing. At this date, at this time, I send request like this. It has taken 63 milliseconds to process the request. But when you go for welcome API, so clearly it is showing that you send the request for the welcome internally communicate with the greet. That means it is showing inter-service communication. So here, second time when send the request, it has taken very less time. For welcome API, I made a request and it has taken total 12 milliseconds. In the 12 milliseconds, greet API execution also happened. Greet API has taken 4 milliseconds to process. Total time taken by welcome API is 12 milliseconds. This is the request I have sent. Internally, it communicated with the greet API, start time, start date, and time duration which has taken, and how many services involved in the request processing, we can monitor by using Zipkin server. Zipkin and Slate, they are used for distributed tracing. They are not used for checking the logs of your application, not for the application logs checking. These are used for observability purpose. Zipkin and Slate are used for observability purpose. Observability nothing but how many requests are received by our application, how many times request is received, for which API the request came, how many time it has taken to process the request, which API is involved in the request processing. Clearly, this table is giving the information. When you send the request for welcome API, 2 services involved in the request processing, because welcome API having a FEN client, it will internally communicate with the greet API. When you send the request for the greet API, only greet API is executing. When you send the request for the welcome API, welcome and greet both are executing. So that kind of observability is providing by Slate and Zipkin. So how we have integrated our application with Slate and Zipkin? We have started the Zipkin server. We downloaded the Zipkin jar file and we have started our Zipkin server. Once the Zipkin server is started, you can see the port number is 9411. Then after, whenever we are creating the project, we need to add the Slate dependency, but that is not coming in the IDE. So manually, I have added this Slate dependency, guys. Okay. So now add below dependency in our APIs in welcome API and greet API project form.xml. Okay. Add below dependency in the welcome API and greet API form.xml file. Then what I need to do here, we need to download the Zipkin server jar file, then run the Zipkin server jar file. Run the Spring Boot applications and send a request to the REST controller method. Verify the logs. Go to Jipkin dashboard in order to monitor. So here, these are the steps that we need to follow in order to integrate our application with the Jipkin server with the Slate. So already we have added starter dependency. Cloud Slate Jipkin dependency we have added. Only with the dependency it is not working. We need to add Slate starter. When we add the Slate starter, we are able to access our application. When we access our application in the Jipkin dashboard, we are able to see how many requests we have sent and how much time it has taken to process. So when I click on the run query, currently 3 results are coming. Now let me make one more request for the grid. I made one more request for the grid. Now you see 4th result is coming. Just a few seconds ago, I sent the request for the grid API. 48 milliseconds it has taken. Now send the request for welcome API. Then refresh, 5th result will come. Just a few seconds ago, I have sent the request for the welcome API. It has taken 158 milliseconds. So how many requests we are sending and which services involved in that, we are able to process that. Service filters. I want to monitor only grid API. So now you can check the service filters and you can monitor those results. When I select the welcome API, only welcome API results I'm getting. Suppose if I remove this and if I select as a grid API and only grid API results will come. If I select welcome API, only welcome API results. Service filters also can be done. How many services are registered with the Jipkin? Those service names are coming. In our application, 2 backend services are available. Those backend services I'm able to access. Okay. Now here, if you want to monitor based on the time limits also you can do. Last 1 minute, I want to check that. In the last 1 minute, only one request is sent. We can check this. So here, timings also you can configure. Last 5 minutes, run the query. In the last 5 minutes, I have sent 2 requests. Like this, we can configure. We can check that. Okay. Welcome API, grid API. So here they are providing in the graphical format as well. If you want to check with the particular service name, so the service name grid API, and you can give run query. So it will give only grid API results. If you give service name is equal to welcome API, then click on run query. Only welcome API results are coming. So like this, you can observe the application tracing by using Jipkin and Slate. So I hope you got the clarity. What is a Jipkin server and why we need to go for Jipkin server? Are you guys able to follow me? What is the purpose of Jipkin server and why we need to go for Jipkin server? Guys, are you clear with this point? What is the purpose of Jipkin server? Why we need to go for Jipkin server? Jipkin server is used for observability purpose. What observability? So how many requests are coming to our application? How much time is taken by each request to process and which services are involved in the request processing that can be identified by using Jipkin server. So with this, we are able to complete our microservices project. We are able to create the service registry, that is Eureka. Service registry is used to register all the services available in our application. Admin server is used to monitor and manage our application actuator endpoints at one place. Jipkin server is used for observability purpose. And we developed backend APIs, grid API and welcome API. We are able to establish inter-service communication between these APIs by using FIAN client. And we are able to implement load balancing by using Ribbon. And we are able to implement API gateway that is used to manage all the backend APIs of our application. In the API gateway, filters are available and routings are available. If you want to implement some security, instead of implementing that security in all the APIs, we can implement that in the API gateway by using filter. At one place, we can implement security for all the backend APIs. API gateway will forward the request to the actual API by using routing. We have configured the routing as well. Now here, if you observe, welcome API, grid API are called actual backend APIs. This welcome API and grid API acting as clients for Eureka server, acting as a client for admin server, acting as a client for Jipkin server. My welcome API, greet API are called as actual microservices. Those are my REST APIs. In the project, we may have 20 REST APIs, we may have 30 REST APIs, we may have 100 REST APIs. Our REST APIs are acting as a client for Eureka server. Our REST APIs acting as client for admin server. Our REST APIs are acting as client for Jipkin server. Are you guys clear with my point? Are you guys clear with my point? Now you got the clarity on microservices architecture. What is the role of service registry? What is the role of API gateway? What is the role of admin server? The role of Jipkin server? The role of PN client? The role of API gateway, filters, and routings. Good. So as of now, we discussed what is monolith architecture. As of now, we discussed what is monolith architecture, and we discussed drawbacks with monolith architecture. Drawbacks with monolith architecture. What is monolith architecture? Drawbacks with monolith architecture. Microservices introduction. Microservices introduction. Pros and cons of microservices architecture. Pros and cons of microservices architecture. Here I can say pros and cons of monolith architecture and pros and cons of microservices architecture. Pros and cons of microservices. Then we discussed about microservices architecture. Microservices architecture. Then finally, we discussed about service registry. So for the service registry, we are using Eureka. Eureka is a Spring Cloud component. Using Eureka, we are creating our service registry. And we discussed about admin server. Admin server, monitor and managing actuators. Monitor and manage actuators. Actuators of all the APIs at one place. Then we discussed about Jipkin server with the Slate. Jipkin server with the Slate. Slate dependency should be available. Then only our applications are connecting with the Jipkin server. Slate dependency we added, Jipkin server we downloaded, and we have started. Right. Then after we developed our backend APIs development. Backend APIs development, greet API and welcome API. So in the real time, those APIs will be different. Admin API, user API, products API, payments API, like that. Backend APIs development will be available. So now, once the backend APIs development completed, we are able to implement inter-service communication for them. Inter-service communication. For inter-service communication, we are using PN client, and we are able to implement load balancing with Ribbon. Instead of running my API in one server, I'm running my API with multiple instances for the load balancing with Ribbon. And we understood API gateway. API gateway, that is a front gate of all backend APIs. Filters and routings in the API gateway. Filters and routings in API gateway. So this is what we have learned as of now in our microservices development. What is monolithic architecture? Developing all the functionalities in single project is called as monolithic architecture. Pros and cons of the monolith. Development will be easy with the monolith, but maintenance will become very difficult with the monolith architecture. If you make any small change in the application, then the whole project should be redeployed. That is a problem. So to overcome the problems of the monolith architecture, we are going for microservices. Microservice is not a programming language, not a framework. Microservices is an architectural design pattern to develop our applications. When we develop our application with microservices, loosely coupling will be available. What are the pros and cons of microservices? So bounded context problem will be there in the microservices. Visibility problem will be there. Lot of configurations we need to do in the microservices. Advantages: easy maintenance, fast development, quick releases. and technology independence can be achieved in the microservices. Microservices architecture. So like this, microservices architecture will be available in the project. Service registry will be available. Admin server will be available. Jipkin server will be available. PN client will be available. API gateway will be available. Service registry, it is used to register all the services at one place. It will maintain names of the services, status of the services, and URLs of the services. Okay. Then admin server. For in the backend, multiple services will be available. Monitoring all the backend services, actuators one by one is very difficult. I want a single user interface to monitor all the backend APIs at one place. To monitor all the backend API actuator endpoints at one place, we are going for admin server. Are you clear? Now, so here, next one, Jipkin server. I want observability of my application. Observability, nothing but distributed log tracing I want to do. How many requests are coming to my application and which services involved in the backend to process that request? How much time has it taken by each request to process? That can be identified by using Jipkin server. Backend APIs development we have done. We created two backend APIs. One is Welcome API, another one is Greet API. For these backend APIs, I established inter-service communication. Inter-service communication means one API will communicate with another API. To implement that inter-service communication, I used a concept called PN client. What is the benefit with the PN client? By using PN client, without configuring the URL of one API, you can access that. By using service name, we can communicate with another API by using PN client. PN client will dynamically get the service URL from the service registry for the communication. Service can have multiple instances. When the service is having multiple instances, PN client will communicate with the ribbon for the load distributing. When multiple instances are running for the Greet API, in the round robin fashion, PN client will communicate with the Greet API. Welcome API will call the PN client method. PN client will call the Greet API by using ribbon, load balancing. Then load balancing we have implemented with the ribbon. Load balancing means if you run your application in one server, all the requests will go to single server. That server may not be able to handle the load. To distribute the load to multiple servers, instead of running our API in one server, we are running our API in multiple servers. Those are called as instances of our APIs. Those are called as instances of our APIs. So by passing the port number dynamically as a VM argument, I'm running these instances. One API can have multiple instances. That depends upon your system configuration, how many instances you want to run. The next one, API gateway. Some common logics I want to write for several APIs like security. Instead of doing that common logics in all the APIs, we will take one front gate for all the APIs. API gateway is used to manage all the backend APIs at one place. Suppose whenever a request comes, I want to validate that request. Instead of writing that logic in all the API, we can keep in the API gateway. API gateway will act as a mediator between incoming requests and backend APIs. In the API gateway, we are using Spring Cloud Gateway. Spring Cloud Gateway concept is available to work with the API gateway. Earlier, people used it to work with the ribbon. People used it to work with the Joule for the API gateway. But in the latest versions of the Spring Boot, that Joule is not working. They replaced Joule with the Spring Cloud Gateway. We are using that Spring Cloud Gateway. In that API gateway, we have implemented a global filter. That filter will print all the headers which are coming. You can validate the header data. Then only you can decide whether to process the request or not. And in the API gateway, we configure routings, which every request which is coming to our application should go through API gateway. API gateway will execute the routing rules. The routing rules will decide which request should be processed by which API in the backend. So this is what we have learned so far. This is what we have learned so far in our microservices concepts. And next, what we need to understand? We need to understand what is a config server in the microservices, how to communicate Spring Boot with Redis server, how to communicate with Apache Kafka by using Spring Boot, and how to configure circuit breaker in our microservices for resilience systems. Those topics we have to understand. Yeah. Before proceeding further, anybody having any questions on this project implementation?
Yes, sir. Hello.
Yes, sir.
Sir, what is the use of span ID and trace ID?
those are trace ID. For one request, one trace ID will be available. In every API, span ID will be available. Based on the trace ID and the span ID, Zipkin will store the information of your services. So if Zipkin wants to provide the observability, then trace ID, span ID required for that Zipkin. That will be used by Zipkin server.
Okay. Thank you.
Hello, sir.
Yes.
Can we say that using Zipkin server, we are doing distributed tracing?
Correct.
Okay.
The main purpose of Zipkin server is distributed tracing.
Okay, sir.
Sir, Zipkin server real time also using?
Yes, sir. Some projects will use Zipkin server. I told you that, right? This architecture is not fixed. Some projects will follow that. Some projects will not follow. It depends on project.
Yes, sir.
Depends on project.
Real time. Which one is recommended? Because API gateway we are using Spring Cloud, service registry we are using Eureka.
Sir, if your project is using cloud like AWS cloud or Azure cloud gateways, they will configure.
Okay.
Okay. So one of the gateway that most of the projects will use in the real time, that is APG. Okay. That is a paid API gateway that is given by Google. APG people will use in some projects. If your project is not using any cloud, then this Spring Cloud gateway we can use open source.
Okay.
Hello, sir.
Yeah, hi.
Can we design few backend APIs with service layer logics?
You can implement. So whatever the REST API I have created is the
No,
welcome REST
just in
control.
class means in Spring Boot classes and in microservices, we design only the mass string returning APIs only.
That is what, man, you can write your database logic also here. Now you got the clarity how the architecture looks like, right? Now here greet API is available, welcome API is available. Instead of the greet API and welcome API, you can write the logic and you can communicate with the database. You know already data JPA and how to communicate with the database. You know that logic. Logic will change from project to project. I have given you the overview architecture of the microservices. If you want to write some business logic in that, you can implement that business logic. You got my point?
Yes.
Hello, sir.
Yeah.
Sir, in my office, they want me to, they asked me to develop a microservices which will use a Spring and it will provide a data analysis kind of stuff, sir, with graphs. Is it possible that we have some dependencies which can do it apart from Apache Spark?
Sir, graph representation that will be done at the UI side. D3.js will be used for that. D3.js, some people will use the Jasper reports. In the Spring Boot, there is no direct dependency to generate the graph. For the graphical development, you need to use the third-party JS libraries like D3.js is available for the graph. Spring Boot will give you the data that you need to use there. Someone asking what is the difference between Zipkin tools and Grafana. Grafana is basically used to monitor your Kubernetes cluster. Visualized cluster monitoring will be done with the Grafana. So there is no relation between our Spring Boot and Grafana. Grafana is used to monitor visually what are the services are running, what is the performance of that, how much memory consumed by our service. So how much memory consumed by our machine, what is the CPU utilization, that can be monitored by using Grafana. The purpose of Zipkin and Grafana both are completely different. You got it?
But sir, hello sir. But in Grafana also we can see the which request is going on which server.
You can monitor that also. Grafana is also one of the server that will be used in the Kubernetes clusters.
Same thing we can do in Grafana also.
Yes, right. All good with the microservices architecture?
Hello. Hello,
Yes.
sir.
Yes, sir.
Here we are using the Eclipse to create the multiple instance of the welcome API and greet API.
Yes.
Okay. And in product, suppose if you deliver the codes, okay, with one application.
They will deploy your application as Docker containers.
Docker container, then how they can generate multiple instances?
In the Kubernetes, there is an option called pods. So they will scale up your pods. So every API will run in one pod. For one project, they will create for one application, they will create multiple pods. One pod will represent one instance. In the Kubernetes, so in the real deployment will happen on the Kubernetes. In the Kubernetes, they will increase the pods count, decrease the pods count. One pod will represent one instance of your application. That will be taken care by operations team, not the developers.
Okay.
Yeah.
And this question was frequently asked in interview.
So you tell them that in my application deployment will happen in the Kubernetes. In the Kubernetes, we will implement load balancing for our application. That will be taken care by DevOps team, not the developers.
Okay. And I, due to some issues, okay, I couldn't attend. Okay, attend the classes. Okay, I have one doubt. Okay, in API gateway, we only we configure the routing logic and filters, and there is no controller classes. I think.
No, nothing. API gateway is for filtering the requests and for the forwarding the requests. That's it. We don't create any controllers in the API gateway. We don't need that. Controllers will be available in the backend APIs, right? Our APIs will contain the logic.
Okay, only properties files we have to implement logic only in properties files, application or properties files.
Correct.
For
That
filter purpose, for routing purpose, we can implement the interceptor or any other logic.
You were confused. Filters will be implemented there and routings will be there in the YML.
Routing will be?
Routing configuration will be there in the YML file. Filtering logic will be implemented by using filter classes.
Filter classes, yes. Okay, yes.
Right.
Thank you.
Hi, sir.
Yeah, hello.
If we are using microservices in our project, can you please tell me what are the responsibilities as a developer we have to do that?
You need to develop your REST APIs. That is your responsibility.
Okay.
You need to develop your REST API. Your REST API should be able to communicate with the config server. Your REST API should be able to communicate with the Redis cache. Your REST API should communicate with the message broker, inter-service communication that you will implement. The remaining parts will be taken care by operations team. Deployment and all, running the application with the multiple instances, that will be taken care by operations team. As a developer, you will focus on your business logic development.
Okay.
So resiliency, circuit breaker, these things also asking. Right?
Yes, sir. That is part of our syllabus. The circuit breaker, config server, Redis cache, message broker. Yeah, we will be covering those things.
Yeah, thanks.
Yeah,
Hello,
fine,
sir.
guys. Yes, tell me.
Yes, sir. In coming to circuit breaker, sir, will you cover Hystrix also?
Yes, sir. Hystrix, circuit breaker with Hystrix actually outdated. Sir, Resilience for J is the latest. Hystrix is outdated, not supporting by latest version of the Spring Boot.
Yeah, but in the interview, they asked so many questions from Hystrix only. That's why I faced lots of questions from Hystrix.
Yeah, we'll cover that.
Okay, sir. Thank you.
Fine, guys. If anybody has not done this project implementation, please complete this project implementation. So tomorrow we are going to work with the remaining tools like circuit breaker, config server, Redis cache, and all that stuff. Thank you. With this, I'm stopping for today. So you have time, please complete the project setup. Then only we'll get the practical approach clarity on the microservices. We'll continue in the tomorrow's class. Thank you, guys.